Okay, so here we've got two tutorial questions which takes into account everything we've done in section 1.2. So here they ask us for which values of A will the following system have no solutions, exactly one solution, or infinitely many solutions. Okay, so you're given this, you're given that unknown value A, and you need to determine for which values of A that this system will have one of those three options. Right, so we can do this with Gaussian elimination. So let's write down the system and find its augmented matrix. Right, so there you've got your system, and the next step obviously is to write down the augmented matrix. Right, so the first column, for it by taking those entries there. Second column, taking those entries there. Third column. And then the fourth column. Right, so that is my augmented matrix, and now I need to play around with Gaussian elimination. Right, so again, as we described in the theory part, you select the leftmost column that's got at least one non-zero entry, which is this column here, and then you select a non-zero value, either 1, 3, or 4. And you place it as high as possible. You place it right up in the first row by interchanging rows if necessary. I can either start with 4 or with 3, but then it means I'm going to have to do a little bit more work. So I'm not going to start with 4, 3, I'm going to start with 1, because I've already got a non-zero there placed as high as possible. So I'm going to use 1 as my leading entry in my first row. So using that, I want to create a 0 and a 0 there. Right, so I'm going to change the second row by adding -3 times the first row to it. So that's going to be -3, -6, 9, and -12. Right, and then adding that to the second row, we get first entry there is 0, second entry is -7. Okay, the next entry is going to be 9 plus 5, which is going to be 14. And the last entry is going to be 2 minus 12, which is -10. Right, next up we're going to change the third row. And we're going to do that by adding to it -4 times the first row. Okay. Right, so doing that then, again, what you do, you write in pencil. This is, the blue is what you write in pencil. So you get -4 there. You get -8. You get 12 there. And you get -16 there. Alright, and then you add it to the last row, so that's going to become a 0. Then that is going to become a -7. Okay, and 12 plus a squared minus 14 is going to be a squared minus 2. So that's going to change to a squared minus 2. And then -16 plus a plus 2 is going to be a is going to be a minus 14. Okay. Right, so now you've created your leading entry in your first row. So now we need to move on to my second row. You choose the leftmost column that has at least one non-zero entry. It's not that one. It's this one here. And now we look at a non-zero entry below the black line. It's minus 7, and we want to place minus 7 as high as possible. I'm going to take this minus 7 here, and then you use it to reduce everything below it to 0 in that particular column. Right, so what I'm going to do is I'm going to change the third row by adding minus the second row to it. Alright, so that is going to be 7. That's going to be minus 14. And that's going to be 10. Right, so adding that, we get 0 there. Minus 14 plus a squared minus 2 is a squared minus 16. And then a minus 14 plus 10 is a minus 4. Alright, so let's just make a leading one in the second column, in the second row I mean. So we're going to take... Right, so let's just make a leading one in the second row. So we can do that by taking the second row and multiplying through by negative 1 over 7. So that becomes first entry is going to become 1. Second entry is going to become minus 2. And the last entry is going to become 10 over 7. Right, so let us consider the first case. Let's consider the first case. Okay, that is, so now one has to just fiddle around a bit. Let's look at the case where a squared minus 16 is 0. Okay, so so when a squared minus 16 is 0, then a minus 4, a plus 4 is equal to 0. And this is going to imply implying that a minus 4 is 0, or a plus 4 is equal to 0. Right, so hence a is 4, or a is minus 4. Now, if carrying on, if a is minus 4, then our matrix is going to become what? There's our matrix. If we make a equal to minus 4, this a squared minus 16 term is going to become 0. Okay? And this term is going to become minus 8. And in this case, we see that if we go and write down the linear system corresponding to those equations, we have that the last The last row corresponds to the system 0x plus 0y plus 0z is equal to minus 8. Okay, and that is clearly an inconsistent system. Okay, so then just to complete that, so the system is clearly inconsistent. Right, so that is if A is minus 4. Right, if A is 4, then again the A squared minus 16 term is going to become 0. And the A minus 4 term is going to become 0. Right, so just further reducing the matrix a little bit, we can just change the first row by adding minus 2 times the second row to the first row. Right, so multiplying the second row with minus 2, we get the first entry minus 2, second entry 4, and the last entry minus 20 over 7. And then we're going to add it to the first row. So the second entry in the first row is going to become 2 plus minus 2, which is 0. A third entry is going to be 4 minus 3, which is 1. And the last entry is going to be 4 plus minus 20 over 7, which is 8 over 7. Right, now it's important to note that the two matrices that I've written there, you shouldn't write an equality sign between the two whenever you operate or do an operation, because the two matrices are not the same. So I'm using an implication sign to indicate that I'm moving from one matrix to the other via an operation. Right, so that matrix then corresponds to a linear system of equations, and let's write that linear system down. So that corresponds to x plus z is equal to 8 over 7. Okay, and also just note that the variable, the two encircled leading ones, they correspond to the variables x and z respectively. Okay, so the second equation becomes y minus 2z is equal to 10 over 7. And previously we identified the two leading variables being x and y respectively. So z is a free variable. So we parameterize the variable z as an arbitrary real number s. We get from 2 that we can solve for y, and we can solve for y as 10 over 7 plus 2s. And then from 1 we can also solve x as 8 over 7 minus s. Right, so having solved x and y, we can then write down the solution space of the linear system. So it's all points where the x component is 8 over 7 minus s. Y component is 10 over 7 plus 2s, and the z component is s. Right, and s is a parameter as we described. It is a real number. So s is any arbitrary real number. Right, so it is clear in this case that the linear system will have infinitely many solutions, because I can choose s to be any value, any real number will do. So the system has infinitely many solutions when the value of a is equal to 4. Right. Okay, so let's move on to the next case, and that's case 2. Case 1, we considered the case where a squared minus 16 is 0, And now we're going to consider the case where a squared minus 16 is not equal to 0. So a squared minus 16, we can assume, because it's a non-zero number, we can divide the last row by a squared minus 16. And that is exactly what we're going to do now. Okay, writing our matrix down, we factorize the last row, the term a squared minus 16 into a minus 4 times a plus 4. And remember now I can divide the last row with a minus 4 times a plus 4 because it's a non-zero number. Right, so I'm going to change the third row by multiplying the third row with 1 over a minus 4 multiplied by a plus 4. Okay, so that's the term that I'm going to multiply the third row with, 1 over a minus 4a plus 4. So the first non-zero entry in the third row is going to become 1, and dividing a minus 4 by a squared minus 16 gives me 1 over a plus 4. Now I need to create zeros above the leading ones. So I start with the leading one in the third row. I'm going to change the second row by adding twice the third row to it. So I get 2 and 2 over a plus 4. Adding that to the second row, the entry above the leading one in the third row becomes 0. And then the entry in the last column becomes 10 over 7 plus 2 over a plus 4. So we need to create another zero term in that column. We need to get rid of the minus 3. We need to make it a 0 because we want to create zeros everywhere above the leading one in the third row. So what I'm going to do is I'm going to change the first row by adding 3 times the third row to it. Multiplying the last row with 3, I get 3 and 3 over a plus 4. And then adding that to the first row, we get a new matrix. The last row is going to stay the same. Okay. The second row of the matrix is going to stay the same. Okay, and it's only the first row that's going to change. So the first entry that's going to change in the first row is the term 3 plus minus 3, which is 0. And then the last entry in the first row is going to become 4 plus 3 over a plus 4. Okay, so that's my new matrix. Right, taking that matrix, I need to create another 0 above the leading one in the second row. And I can do that by changing the first row. And I do that by multiplying the second row with minus 2 and adding that to the first row. Okay, so multiplying the second row with 2, I get minus 2. And then that last term I'm going to multiply with minus 2. And that's going to become minus 20 over 7 minus 4 over a plus 4. Okay. Now I'm going to add that to the first row. So I get a new matrix, well, the last row is still the same. Then the second row is also going to stay the same. Right, and it's only the first row that's going to change. So the first term in the first row that's going to change is the second entry, and it's going to become 0, 0, and the last entry is going to become 4 plus 3 over a plus 4 minus 20 over 7 minus 4 over a plus 4. Okay, that's my new matrix. Right, so from here we can now by inspection read off the values for x, y, and z respectively. So taking that just the last term in the first row and just simplifying it, we get 8 over 7 minus 1 over a plus 4. And then we can go and read off our values. So x is solved as 8 over 7 minus 1 over a plus 4. Y is solved as 10 over 7 plus 2 over a plus 4. And z can be solved as 1 over a plus 4, where a plus 4 is a non-zero real number. Right, so recap. We said the system has infinitely many solutions if a is equal to 4. We solved that previously in the previous case. Second, we showed that the system is inconsistent if a is minus 4. Okay, and lastly, we showed that whenever a is a real number that's neither 4 nor minus 4, we showed the system has a unique solution. We can solve for x, y, and z explicitly. Right, so that answers the question. We've done a detailed analysis on where we have those three cases. Okay, next up we've got question 2. We're given a cubic equation. Y equals ax cubed plus bx squared plus cx plus d. And we are given 4 points that lie on this cubic equation. 0, 10, 1, 7, 3 minus 11, and 4 minus 14. So given these 3 points that are given to lie on the cubic equation, they ask us to use Gaussian elimination to solve for a, b, c, and d. Okay, so writing that down, those are the 4 points that are given to lie on the function y equals ax cubed plus bx squared plus cx plus d. And so what we're going to do is now we're going to set up our system of linear equations. So we're first going to take the point 0, 10, and we're going to plug it into our cubic function. So there we're going to take the cubic function. We are going to delete the x's and replace them with 0. Okay. And we're going to replace the y value on the left with the value 10. Right, so making y equals to 10, the left-hand side must equal to the right-hand side. And on the right-hand side, we get d. So therefore, we've solved our first unknown. We've solved for d as 10. So our cubic function becomes that ax cubed plus bx squared plus cx plus 10. We take the next point, we plug it into the linear equation, we delete the x's and replace them all with 1. Right, and then we take the y value and we replace that with 7. So on the right hand side we get a plus b plus c plus 10, and on the left hand side we get the value for y, which in this case is 7. Right, so it simplifies to a plus b plus c is equal to minus 3. And that is our first equation. So taking this, the third point, we do the same. We take our function again. What we're going to do now is we're going to delete the x's and we're going to replace them with 3. Right, so that is the term that we get on the right hand side. And what we have on the left hand side needs to equal y. And we basically just simplify what we have on the right, which we'll do now. So we replace y with minus 11. And the left hand side needs to equal to the right hand side. So that then implies that our left hand side stays minus 11. And our right hand side is replaced with 27a plus 9b plus 3c, and that is going to equal minus 21. Okay, so that is going to be our second linear equation. Then taking the last point, we just do the substitution, and again we take our polynomial, the right hand side of the polynomial, we delete the x's and we replace them by 4. Right. Okay, so there we get, again we take the y value on the left hand side and we replace that with minus 14, and we need to have equality between the left hand side and the right hand side. Okay, so simplifying, we get minus 14 on the left, 64a plus 16b plus 4c plus 10 on the right hand side. And then what we do is we just do a little bit more simplification to get our third equation. So we're going to be left with 64a plus 16b plus 4c is equal to minus 24. So that is my third equation. So now I've got a linear system with 3 equations and 3 unknowns, and we know how to solve that using Gaussian elimination. We set up a augmented matrix. Okay, and the first row of this augmented matrix is going to be 1, 1, 1, minus 3. Second row is going to be 27, 9, 3, and minus 21. And the last row is going to be 64, 16, 4, and minus 24. Right, so taking that matrix now, we use Gaussian elimination. So to start off, we select the leftmost column that has at least one non-zero entry, and the leftmost column is the column 1, 27, and 64. Right, so I can either choose 1, 27, or 64. I'm going to choose 1 because 1 is a non-zero value and it's already in the highest position. So I'm going to use 1 as my leading entry in my first row. Right, so then I'm going to make things a little bit easier. I'm going to manipulate the second row by dividing each entry with 3. So I get 9. Then the second entry I get 3. Third entry I get 1. And the last entry I get minus 7. That's just going to make things a little bit easier. Then I'm going to make the last row a little bit easier to work with as well. I'm going to divide straight through by 4. So I'm going to multiply with 1 over 4. So that first entry is going to be 16. Second entry is going to be 4. Third entry is going to be 1. And the last entry is going to be minus 6. Okay, now for my leading one in my first row, I'm going to create zeros under it. So the first zero I'm going to create is I'm going to do that by changing the second row by adding minus 9 times the first row to it. So multiplying the first row with minus 9, I get minus 9, minus 9, minus 9. And the last entry there, I'm going to get minus 3 times minus 9, which is 27. And then I'm going to create a new matrix where the last row is going to stay the same. It's going to be 16, 4, 1, minus 6. The second row is going to change to 0. The next term is going to be 3 minus 9, which is minus 6. Next term is going to be 1 minus 9, which is minus 8. The last term is going to be 27 minus 7, which is going to be 20. Okay, and again, the first row is going to, for now, it's going to stay the same. Okay, that's my new matrix. I have another 0 to create under the leading one in the first row. So I take my matrix as it is, and I'm going to change the third row by adding minus 16 times the first row. So multiplying the first row with minus 16, I'm going to get minus 16, minus 16, minus 16, and then I'm going to get plus 48. Okay, now adding that to the last row. The last row is going to change. So I'm going to get a new matrix where the second row is going to stay the same. The last row is going to change to 0. 4 minus 16, which is minus 12. Minus 16 plus 1, which is minus 15. And 48 minus 6, which is 42. And then again, for now, the first row is going to stay the same from the previous matrix. Okay, so that is my new matrix that I have to take a little bit further. Okay, now we're going to look at the leftmost non-zero column. If we delete the first row, and the leftmost column is that encircled column. Now I've got two non-zero entries there, so I can pick either one. I'm going to pick minus 6 because that's already a non-zero entry, and that's as high as possible below the black line. So now I'm going to use this to change the third row. So the third row is going to be changed by multiplying the second row with minus 2 and then adding that to the last row. So multiplying minus 6 with minus 2, that's 12. Minus 2 times 8 is going to be 16. And then minus 2 times 20 is going to be minus 40. So now I'm going to create a new matrix. The first and the second rows are going to stay the same. It's only the third row that's going to change. Right, so the first row stays the same, second row stays the same, and the last row is going to change to, first entry is going to stay 0. The second entry is going to change to 0 because it's 12 plus minus 12. Entry is going to be 16 minus 15, which is 1. The last one is minus 40 plus 42, which is 2. Right, so now I want to create zeros above the leading one in the last column. So I'm going to do this by changing the second row by adding 8 times the third row to the second row. So I get a new matrix. The first row is going to stay the same. The last row is going to stay the same. And the second row is going to change to 0, minus 6, 0, and the last term is going to be 36. Okay, so that is my new matrix. Alright, so taking that matrix, and then what I'm going to do is just make a leading one in the second row by multiplying the second row with minus 1 over 6. So the first term there is going to become a 1, and the last term is going to be 36 divided by minus 6, which is minus 6. Right, so the next thing is creating zeros above the leading one in the last row. So I do this by changing the first row by adding minus 1 times the third row to the first row. So I get a new matrix that is going to have the last row stay the same from the old one. The second row is also going to stay the same. That's going to be 0, 1, 0, minus 6, and then the first row is going to change. So the first entry in the first row that's going to change is going to be the entry in the third column. So there we've got 1, 1, that's going to become 0, and the last column entry is going to become minus 5. And that comes from minus 2, minus 3. Okay, so I've created zeros above the leading one in the last row. As one can see there, I have created zeros below the leading one in the first row. As one can see there also, I've also created a 0 below the leading one in the second row, as one can see there. The last thing left for me to do is to create a 0 above the leading one in the second row. I do this by changing the first row by adding negative the second row to the first row. Okay, so we multiply the second row with -1, we get -1 and 6. We get a new matrix which has the last rows going to stay the same, 0, 0, 1, 2. And then we're going to, the first row is going to change. This matrix is still going to have the same second row. And so the first row is the one that's going to change, as I said. So the first entry that's going to change is the second entry in the second column of the first row to 0, 0, and 1. And that comes from 6 plus minus 5. Right, so taking my matrix, we can read off the values. We can solve for A as 1, we can solve for B as -6, and we can solve for C as 2. Right, and so we've got all our values. So our function is going to then become right, so we plug those values in and we get 1x cubed, we get -6x squared for the B part, and then we get plus 2x for the C part, plus 10. Alright, so that is our polynomial.